Alright, Andre, in this video I'm going to be talking about the whole collision system. So, let's just start with the collidables first. So, in the collidables itself, obviously I changed a bunch of things since last semester, and obviously from what you've seen over this entire semester. So, pretty much I still have the registration deregistration pointer to the command base. I have a model pointer. I have every single model, no matter what, will always have a default B-sphere. There is a pointer to a collision volume and then a collision volume type. Basically, all this class does, it registers collisions, deregisters collisions, recycles commands if they were already used or already set, gets collision volumes, and then it will set the collider model type, whichever is called from the user created stuff. So obviously it takes in a model, and then whatever the user says, sets them, and then if the volume type is B-sphere, AABB, OBB, the appropriate collision volume will be set for that. And then we have the update collision data, which is always going to be used within the user classes to compute B-spheres, compute AABBs, and OBBs. Otherwise, they wouldn't be moving or updating or resizing or doing whatever, I guess. So then we'll go to the collision volumes themselves. So, collision volumes are right here. So obviously now I have a million of them, but there's a collision volume base class, which will have the intersections for any kind of collision volume. B-spheres, AABBs, OBBs, they share the compute data function and the debug view. So let's do the boxes. So the boxes have a base class, which they share. They get the min-max, get a world, a center, a horizontal, diagonal, a scale factor, and then they sit min and max corners. So that the boxes can actually be resized. So AABB pretty much inherits all those functions. And then sets and the constructor just sets corner, max, and min just something, so then it's set and just doesn't give null variables. But the collision volume, if you give it a min and a max, it'll set the min max, and it'll resize the center, or set the center. So the compute data, we'll call the compute data function from math tools, which is this, and it basically just takes in a model, matrix, min and max, sets the new min and maxes depending on what is, bigger, and then that's it for that, and then, sets the half directional, the center, the scales for XYZ, and then sets the world. And then if you do compute data and you give a min and a max, so this other one was just a model and a max, and this was a min and a max, sets those min and max corners, computes the center, the half directional, it'll compute the center again, and then it'll do the scale factor. Debug view obviously shows the AABB, which is obviously the same for every single one, in their respective classes. But basically just shows the AABB from this, shows the scale, the rotation, the translation, and then submits stuff in the visualizer, which I'll get to soon. And then these are just accessors. Same thing pretty much for OBB, inherits everything from the box base class, and does the OOB, lots of accessors here, has the intersection functions like AABB, for any kind of collision volume, a B-sphere, AABB, OOBB, or OBB. And then it calls the compute data function from the math tools, which basically just gets the min and max of an AABB, and then sets basically everything: the half directional, the maximum, the minimum, corners, the center, the scale factors, and then the world. Pretty simple. And then debug view, same thing. Just like the AABB one. Scale, translation, world, then submits an OBB to the visualizer. And then I will show pretty sure it's just the B-sphere, really. B-sphere is right here. A little bit less than the other classes, but still something. Has all the intersections, compute data, debug view, and then it has a get center radius. I'll show you that. So basically the compute data, computing a B-sphere, just sets a column, sets a scale, and then sets the center of whatever you gave it to center times matrix, and then radius is radius times scalar, so not that much different. Well, it is different than the other ones, but I mean, it's the whole same shebang. And then here are the intersection. I should probably actually just show you these really fast. So this is intersection with collision, just any collision volume, which calls this. So it calls that any collision. This is collision. You know what? I'll show you this in the PW math tools section. That'll be easier. So yeah, I'll show you these in a minute. But debug view, same thing. Shows a B-sphere. This one obviously sets all of the vectors within the matrix of the B-sphere, and then sets the world matrix, and then submits a B-sphere to the visualizer. Then collidable groups. Yes, the collidable groups, and then collision manager, collision test. Okay. So, grouping. Collidable groups. I really didn't change much in this class. I mean, I'll get to, obviously, yeah, I didn't really change much. There wasn't really much to change. So that's fine, but I did change stuff in the collision test commands. So I'll show you the pair first, because that was like the biggest one. So obviously from last semester, it was not this at all. So this time, we have an update collision group, which will loop through each of the collections and set the min and the max points on each of the collision volumes. So that does all that, and then we go into the execute function, which pretty much has a 4-step collision testing process. So first we have to update the big AABBs around the collidable group 1, and then collidable group 2, and then we update the big AABB around each collidable group. This is called once, and then we need to create temporary big AABBs around each of them, because otherwise the system crashes. So test 1 basically just tests the intersection between the big AABBs and the collidable groups. Test 2 here tests the intersection between collidable groups AABB and the other collidable's default B-sphere. So it's still the big AABB with the B-sphere of the other group. And then we go into test 3, which does the intersection between both collidable objects' default B-sphere. And then we do test 4, which will test